Over the past decade, the global energy transition has accelerated at a pace that almost no one predicted. Solar costs plummeted. Wind turbines grew to sizes once thought impossible. Batteries surged into the mainstream. But one technology, long overshadowed by the glamour of electric vehicles and giant renewables, is suddenly at the center of a manufacturing boom that resembles the early days of solar PV megafactories and lithium battery gigaplants. That technology is the humble electrolyzer. And today we are witnessing an unprecedented surge in electrolyzer gigafactories being built across Europe, Asia, the United States, India, Australia, and the Middle East. This is not a small story tucked away in engineering journals. It is a global industrial shift, reshaping supply chains, redefining energy security, and fundamentally altering the economics of clean hydrogen. This is why electrolyzer gigafactories are exploding worldwide, and what it means for the future of the energy transition. To understand the scale of what is happening, we need to start with why electrolyzers suddenly matter so much. Hydrogen is not new. For over a century, it has been used in refineries, ammonia production, methanol plants, and a range of industrial processes. But that hydrogen was almost always produced from fossil fuels, principally via steam methane reforming, which releases substantial carbon emissions. As the world commits to net zero goals and industries search for low-carbon alternatives, clean hydrogen, specifically green hydrogen produced using renewable electricity and water electrolysis, has moved from fringe interest to core energy transition pillar. Steelmakers want it. Fertilizer companies need it. Shipping lines are exploring it. Electricity markets see it as long-duration storage. And governments are supporting it because it strengthens energy security and cuts emissions in sectors that renewables alone cannot decarbonize. As demand projections rose, electrolyzer manufacturers were suddenly thrust into a manufacturing race. But unlike solar panels, which underwent a dramatic scale-up in the 2000s, electrolyzers were still largely handcrafted systems, produced in small batches by teams of engineers rather than automated robotics. This constrained supply drove up costs and slowed project timelines. Developers complained about long lead times and uncertainty in pricing. Many early-stage projects struggled to secure reliable vendors for large-scale systems. It became clear that if the world truly wanted millions of tons of green hydrogen, electrolyzer production had to move from artisanal assembly to gigafactory-scale industrialization. This realization triggered a global shift. Manufacturers began pouring billions of dollars into gigafactories designed to mass-produce electrolyzer stacks, membranes, catalysts, and entire modular systems. These factories adopt the same industrial logic that made Tesla's Gigafactory 1 a milestone in battery manufacturing. Use automation, precision engineering, and supply chain standardization to drive exponential volume growth and suppress costs. That shift is happening now, and the pace is stunning. Global annual manufacturing capacity for electrolyzers was around 5 to 7 gigawatts in 2020. By 2022, it had risen to roughly 11 gigawatts. In 2024, it climbed towards 17 gigawatts. And by 2025 to 2027, industry forecasts predict 50 to 60 gigawatts of annual production capacity if current expansion plans stay on track. To put that into perspective, the world could soon produce more electrolyzer capacity each year than the total cumulative installed base worldwide today. This is the same type of scale jump that transformed solar panels from expensive niche products into the cheapest source of electricity in many countries. It resembles the lithium battery boom, which drove down the price of energy storage and made electric vehicles competitive with gasoline cars. The energy world has seen this pattern before. Scale up manufacturing, automate production, cut costs, and trigger mass deployment. Electrolyzers are following this playbook almost perfectly. Much of the expansion is driven by policy support. In Europe, the hydrogen strategy calls for replacing natural gas-derived hydrogen with renewable hydrogen in multiple sectors. Major funding mechanisms such as IPCEI have allocated billions of euros to support electrolyzer manufacturing, deployment, and innovation. Germany, the Netherlands, France, Spain, and Scandinavia have all accelerated gigafactory investments. In the United States, the Inflation Reduction Act changed the economic foundation for hydrogen by offering tax credits of up to $3 per kilogram for clean hydrogen production. An incentive so generous it instantly made green hydrogen financially competitive in many scenarios. States like Texas, California, New York, Ohio, and Louisiana are now launching hydrogen hubs and supporting electrolyzer manufacturing lines. India introduced the National Green Hydrogen Mission to encourage electrolyzer manufacturing for both domestic use and export. China, which already dominates alkaline electrolyzer supply, is scaling even faster, building new gigafactories and expanding existing lines. Australia is positioning itself as a global green hydrogen exporter, making manufacturing a strategic priority. Saudi Arabia and the UAE see hydrogen as part of long-term economic diversification beyond oil, and are investing heavily in electrolyzer-related infrastructure. The second force pushing electrolyzer megafactories forward is industrial demand. Heavy industries cannot simply electrify the way cars can. Producing steel requires temperatures beyond what electric furnaces can achieve economically. Ammonia production relies on hydrogen as a feedstock. Oil refining cannot decarbonize without clean hydrogen. Shipping companies are exploring hydrogen-derived fuels like ammonia and methanol. Aviation is testing hydrogen-based synthetic fuels. Grid operators need long-duration storage, and hydrogen provides that. These industries do not need pilot-scale hydrogen. They need hundreds of thousands of tons per year. And the only way to meet that scale is to manufacture electrolysis systems in the gigawatt regime. With demand surging, the electrolyzer manufacturing landscape has evolved rapidly. Manufacturers now focus on three major technology types: alkaline electrolysis, PEM electrolysis, and high-temperature solid oxide electrolysis. Alkaline electrolyzers, long the workhorse of industrial hydrogen, are affordable and reliable. China dominates this segment and is scaling it aggressively. PEM electrolyzers offer faster response times and pair well with intermittent renewables like solar and wind. Europe and the United States currently lead this category. Solid oxide systems are still emerging but offer higher theoretical efficiency when paired with industrial waste heat or high-temperature reactors. Because different applications require different technologies, all three categories are seeing gigafactory development. Beyond technology type, the real action is happening in the manufacturing process itself. Gigafactories are automating membrane coating, catalyst deposition, stack assembly, welding, and testing. They are standardizing modules into 1 megawatt, 2 megawatt, or 5 megawatt blocks that can be shipped globally in containerized units. Some manufacturers are using robotic assembly lines adapted from automotive and semiconductor sectors. Others are adopting digital twins for quality control, enabling predictive testing of stacks before field deployment. These innovations are shrinking production time, improving quality, and reducing costs. The repetition that comes with gigascale manufacturing drives a learning curve effect. The more units produced, the cheaper each unit becomes. Solar followed this pattern, and electrolyzers now appear primed to do the same. One overlooked reason electrolyzer gigafactories are exploding is the emergence of global hydrogen megaprojects. These projects, some backed by oil and gas giants, require hundreds of megawatts, or even gigawatts of electrolyzer capacity at single locations. The NEOM Green Hydrogen project in Saudi Arabia will be powered by more than 4 gigawatts of renewable energy and thousands of electrolyzer modules. Europe's industrial clusters in Rotterdam, Hamburg, and the Basque Country are planning pipelines to transport hydrogen between ports, industries, and storage sites. India is building export-driven green ammonia facilities requiring massive electrolysis capacity. The United States hydrogen hubs intentionally designed procurement volumes that encourage manufacturers to expand domestic production. Every time a mega project is announced, manufacturers see guaranteed future demand and respond by expanding production lines. Even with this manufacturing boom, challenges remain. Supply chains for membranes, catalysts, gaskets, and specialty materials are tightening. Some electrolyzer components rely on iridium or platinum group metals, which are expensive and geographically concentrated. Manufacturers are working to reduce catalyst loading, find substitutes, or engineer entirely new chemistries to avoid bottlenecks. Water availability is another concern. Electrolyzers need purified water, which requires treatment systems, and in some regions, desalination, further expanding project complexity. Grid connections can also be limiting for large hydrogen projects. Many developers are now combining on-site renewables with grid power, allowing flexible operation while minimizing downtime. These considerations do not slow the gigafactory trend, they simply shape how the next generation systems are engineered. Meanwhile, pricing dynamics are beginning to shift. As capacity grows, early indications show downward pressure on electrolyzer capex. Some markets already report discounts as manufacturers compete for market share. Analysts expect electrolyzer capex to fall between 30% and 60% over the next decade as gigafactories mature. However, electricity cost still remains the dominant factor in hydrogen production economics. Falling electrolyzer prices help, but cheap renewable energy and smart operational strategies remain essential for achieving $1 to $2 per kilogram hydrogen, widely seen as the threshold for mass adoption in multiple industries. The rapid rise of electrolyzer gigafactories has not gone unnoticed by financial markets. Investors increasingly view hydrogen as a long-term infrastructure play. Funds focused on clean energy, industrial decarbonization, and climate tech are backing electrolyzer companies and manufacturing facilities. Utilities, oil and gas companies, and industrial conglomerates are forming partnerships to secure supply and accelerate deployment. Venture capital, private equity, and sovereign wealth funds are all entering the hydrogen manufacturing space. The result is a global ecosystem of capital supporting the gigafactory explosion. AI and digitalization also play a key role in the growth of electrolyzer gigafactories. AI is being used to optimize manufacturing lines, predict equipment failure, improve stack quality, and simulate thousands of production variables. In field operation, AI-powered systems optimize electrolyzer run schedules based on real-time electricity prices, carbon intensity, renewable availability, and market conditions. This digital layer, combined with scalable hardware, creates the foundation for what many are calling the hydrogen operating system, where electrolyzers become smart, responsive assets integrated into global energy markets. As the scale-up continues, the global map of hydrogen manufacturing is shifting. China is expanding its alkaline capabilities at lightning speed. Europe is strengthening PEM manufacturing and innovating in solid oxide systems. The United States is building strategically located gigafactories tied to hydrogen hubs. India is entering the gigafactory race with the ambition of becoming both a major producer and exporter of electrolyzers. Australia, the Middle East, and South Korea are building hybrid models that combine local use with export-oriented strategies. This is not a single-country competition. It is a global industrial sprint. In the 2030s, electrolyzer gigafactories will likely be as common as solar and battery factories are today. Hydrogen pipelines will expand, industrial clusters will decarbonize, energy storage markets will integrate hydrogen more deeply, and green hydrogen could become as ubiquitous in industry as natural gas is today. All of this begins with gigafactories. This is why electrolyzer gigafactories are exploding worldwide. It is not hype. It is not a bubble. It is a deliberate, well-funded, large-scale industrial build-out aligned with global climate goals, energy security needs, and economic transition strategies. The world needs clean hydrogen, and electrolyzers are the machines that will produce it. Manufacturers are responding, developers are preparing, investors are moving, and the gigafactory revolution is just beginning.